All right, y'all, at this point, you should have finished the activity on discovering the log rules. And now we're going to go through and formalize these, make sure the activity helped us understand it. The first one here, we notice an addition sign between these two logarithms. So with this addition sign here, what that means when we see addition between two logarithms, we multiply the arguments, or what the log is acting on. So our result here would be log base 10. The logarithm itself doesn't change. So log base 10 of 5 times 2, multiplying those arguments, 5 times 2 is 10. Okay? So this should say in words, what is the log rule above? The rule is when adding like bases, because notice both of these logs were base 10, we multiply the arguments. Okay. Next one is we see subtraction happening between our two bases. Again, we check that these bases match up. They do, which means we can combine them. So when we see subtraction here, it means we divide our arguments, or what the log is acting on. We divide. Okay? So again, the log itself is going to stay the same, the log base 10. We divide, so 5 divided by 2, our argument. Okay. So in words, when subtracting like bases, we divide the arguments. Okay. And very, very last one here, when we see a number in front of the logarithm, reminder when a number's right in front or right next to something, and there's no sign in between, we assume it means multiplication. We take that number and we make it an exponent on the argument, or whatever the log is acting on. So this becomes log base 10. Then we have our argument of 5. That 2 becomes an exponent of 2. Moves from the front, multiplied on the logarithm, to an exponent of 2. Okay. Now we can simplify that a little bit farther. This becomes log base 10. 5 squared just means 5 times 5. 5 times 5 gives me 25. So log base 10 of 25. So our rule here, again, these are all supposed to say log rules because you know I can't do anything right. The rule in words is when multiplying a coefficient, in this case 2, in front of the log, move to an exponent of the argument. Okay, so that 2 is being multiplied in front. It became an exponent of 2 on the 5. Now, what we want to look at next is how does this relate to exponent rules? Why did we even care about exponent rules at the beginning? Why did we go over these first? So these questions here says, which exponent rule would you match this with and why? The one I'm going to pick here is our exponent rule from above, where we are multiplying like bases. So I think that this one, this log rule, matches with x to the 5th times x squared, because in the log rule, when we were adding like bases, we multiplied the arguments. With the exponent rule, when we are multiplying like bases, we add the arguments. So we're using the same two operations, just in a different order. Okay? And it's because these are inverse. Okay? Same thing for this next one. The exponent rule I think it matches with is our division rule, because our exponent here tells us that when we are dividing like bases, we subtract exponents. And again, the log rule here says when we are subtracting like bases, we divide arguments. Okay? So again, same operations in the opposite or inverse order. Very last one here, I've got x that I think it matches with our power to a power rule, because here we're taking a power and multiplying exponents. Here we're taking multiplication and turning it into a power. Again, these are inverse operations. Okay. Now the math on these is pretty straightforward. The tricky part is whatever symbol's in the middle signals that something else happens to the arguments. So when I see addition, I multiply arguments. When I see subtraction, I divide arguments. And when I see a number in front being multiplied, I turn it into an exponent. Okay. So now what we're going to do is the practice on the back. I'm going to do the problem on the left, and then you're going to do the problem on the right, the corresponding you try problem. If you would like to pause the video, just pause as you complete these. If you'd like to do it yourself and just check the answers at the end, you are welcome to do that as well. Okay, so on this first one, I see addition here. So I know that addition means I am going to multiply my arguments. So that gives me log base 8, my little base of 8 here, and I am going to then multiply 9 times 4. Okay? I'm going to simplify that down to log base 8. 9 times 4 is 36. So there's my simplified answer. Notice here we are condensing. That is our word here. Condense means to write as a single logarithm, So you should only see the word log once. Okay. On this next one, I see subtraction. When I see subtraction, I know I'm going to divide my arguments. Whoops, kind of at the top of the screen there. So I'm going to write log base 10, my bases match, of 15 divided by 6. Okay, 15 divided by 6. And this can reduce down. If I pop this in my calculator, just the 15 divided by 6, if I pop just this in my calculator, it should reduce down to log base 10 of 5 over 3. So my fraction there can reduce. You don't have to do that, but a lot of times your answer choices will be written that way. Okay, our next one here, I've got a 5 in front. I know if it's in front of my logarithm, that means it becomes an exponent. So this becomes log base 12 of 4 to the power of 5. Whatever number's in front becomes an exponent on the argument. Now when I pop that into my calculator, I'm going to pop it in as 4 to the power of 5. Remember, we're just simplifying this part, so we don't need to pop logarithm into our calculator, which means this should simplify down to log base 12. 4 to the power of 5 is 1024. Okay. Last two. This next one, notice there are multiple logarithm rules here, which makes this a little bit trickier. Okay, I always start going left to right. So I start here, I see that there's a number in front. I see that there's this 3 in front. So the first thing that I'm going to do is write that as an exponent. Okay, so that's going to give me log base 7 of 4 to the power of 3 plus log base 7 of 5. Okay, so the first thing I noticed was the exponent. Next thing I see here is that there is addition. I know that addition means I have to multiply my arguments. So my next step is going to be log base 7 of 4 to the 3rd times 5. And if I pop that into my calculator, just the argument, ignoring the log, if I pop 4 to the third times 5 into my calculator, I should end up with 320. So when you have multiple logarithm rules, I always start from the left and work right, making sure I'm working through order of operations. Okay, here's another one where we see quite a few things going on here. Again, I start left to right. I see a 2 in front. I'm going to move that as an exponent to the argument. So that makes log base 7 of x to the power of 2. And then I write what's remaining, plus log base 7 of 8 minus log base 7 of 5. Okay, so next thing I see moving left to right is this addition sign here. So the next thing I'm going to do is multiply my arguments. So I've got log base 7 of x squared times 8. Those two can't combine, so the best that I can do is write that as 8x squared. That's as much as I can multiply the two of those because x and 8 aren't like terms. So then minus log base 7 of 5. Last thing I see here is this subtraction sign. I know when I see a subtraction sign, it means to divide my arguments. So I've got log base 7 of 8x squared divided by 5. And that is as far as I can simplify that one. I've written it as a single log. Okay? So when you see the multiple rules, work from left to right, tackling or condensing each rule as you go. Okay? Make sure you have completed the ones on the right-hand side. Once you have completed the ones on the right-hand side, we're going to move to the last part of our video, which is converting from exponential to logarithmic form or from logarithmic to exponential form. This is our circle method. Okay? So here I can tell I start in exponential form because I don't see a logarithm and I do see an exponent. What you always want to make sure of is that your single number has to be on the right-hand side of the equal sign. Your single number has to be on the right-hand side of the equal sign. That's true in logarithmic form and in exponential form. So what I do, I know I'm starting in exponential and I need to go to log form. So I draw the framework of my logarithm first. I do log, a box for where the base will be, a box for where the argument will be, and a box for what it's equal to. Okay? That always helps me to draw my boxes. Okay? I always start with the base. I go across the equal sign, and I go back around to convert to log form. So I started with a base of 64. That means 64 is my base. It goes in the little box down here. That's a 64 if you can't tell. Okay? I go across the equal sign to get to 4. That becomes my new argument. And I go back around the equal sign to get equal to 1/3. Okay? So my circle method, whatever I start with is my base. I go across the equal sign to get to my argument, back around the equal sign to get to what it's equal to. Now going in the opposite direction, here I'm starting in log form, and I need to convert to exponential form. So I'm going to set up my 3 boxes again. I have the base of my exponent. I have the 64 here, the big number that's the base. I have what my exponent's going to be, the little number to the right, and then I have whatever it is equal to. Okay, didn't give myself a ton of room here, but I always start with the base. So I'm going to start with my 3. That's my base, so I write it in as my first number. I go across the equal sign to get to 4. That becomes my exponent, and I go back around the equal sign to get to 81. So 3 to the power of 4 is equal to 81. And you can always pop that in your calculator to double check. So draw the boxes first. Make sure your single number is on the right-hand side of the equal sign. Start at the base, go around the equal sign and back to get your order. So this is the first one I went to, second one I went to, third one I went to. So my boxes are first, second, and third. Okay. Hopefully this looks like review from last year, so it's not all too tricky. At this point, I want you to practice the 3 at the bottom. If you finish those, you can go ahead and get started on your homework. And that is it for the video.